Welcome back all. I request our HOD Dr. G. Ramesh to introduce our speaker, Dr. Shyam Sundar.
Good afternoon, everyone. I'm sorry for the small delay in our program for various reasons. I welcome everyone to the last session of the day. The speaker today now is Dr. Shyam Sundar. He's a Chief Scientific Advisor in Azri Private Limited Chennai Mentor and Terra Lumen Solutions Limited Chennai and National Certification Board Indian Society in Non-Destructive Testing. He is an AB Metallurgy from MS University Baroda and PhD from IIT Kharagpur. He has over 36 years of experience as an innovator, researcher, and technologist and trainer. He is a former principal scientist at GE Global Research for over 20 years and former senior scientific officer at IGCAR Kalpakkam for 16 years. Certified as Lean Six Sigma Black Belt, TRIZ Level 3 expert. He has worked extensively in the development of new and advanced NDE inspection techniques, driving the vision and prepared roadmaps for the next generation. He is currently mentoring, advising, and incubating a few startups and pioneering in the adoption of NDE 4.0 and the inspection through digital transformation. Received several prestigious awards like National NDT Award for R&D, GE India's JRD Tata Award for Excellence, GE Whitney Award, to name a few. Now I welcome Dr. Shyam Sundar for this talk. Over to you, sir.
Thank you, Dr. Ramesh, for the introduction. Can someone help me about sharing my slides? Yeah. Is my slides visible now?
Yes, we can see.
Okay, great. So let me minimize this. Okay. Just 1 second, please. Yeah. Thank you, Dr. Ramesh, and thanks for the invitation to speak at this nice seminar. I've been there since morning, very interesting talks, and of course, I deem it an honor to be alongside with the stalwarts of the aerospace industry, Dr. Kota, Lieutenant General Sundaram, and Commander Balaji, and many others who have spoken, Dr. Krishnan. So I do hope I will be able to do justice to the talk in the way they have done it. They have spent years in this domain. My specialization is more in the area of non-destructive evaluation and materials inspection, which also plays a very crucial role. Though I was predominantly in the nuclear industry at the start of my career, and then of course when I moved to GE, I had the opportunity to dabble in aerospace also. So hopefully the audience will find this interesting. It's going to be a run through of several different technologies which I have encountered, which I believe are going to disrupt the aerospace industry, and hopefully it will be a motivation to the student community to take this as a challenge in their career and kind of develop this further. So with that, I acknowledge all the resources which I have borrowed from various sources, and with that we'll get into the talk specific. So the industry spectrum, as you know, is very vast. Be it oil and gas, manufacturing, automotive, and all that. But aerospace, defense, and nuclear always hold a special space in the in any country's development, because they are considered the strategic sectors, and they are sometimes, and not sometimes, in fact always, the leaders. Whatever these three industries do, typically the rest of the industries will follow. And so in that sense, aerospace has a very big role to play, because as they establish technologies and move forward, the rest are watching them and wanting to adopt them. So when we're talking about emerging technologies, you probably, when you browse through Google and other things, you'll see that almost all the major consulting companies in the world, be it McKinsey's or the Deloitte or the Frost and Sullivan and many, they'll always declare a set of technology trends for a given year. And that's based on reviewing several industries and so on. So that's one of the guiding factors always to kind of look at. I wouldn't say entirely, have to take that in toto, but gives you a feel for where things are headed. So the technologies have to evolve and interact. I think that's a very critical thing which I would like to highlight here, that today the world is very multidisciplinary, very interdisciplinary, and you can't just survive any industry with one single technology, one single domain. You have to bring them together, you have to synergize, and you have to interact to create the future. So I talked about in my title about disruption. And what is a disruptive technology? All of us in this today who are there in the seminar have experienced the disruption which the digital technology, the internet, the IoTs have brought in our day-to-day life, right? Imagine how you used to book an airline ticket or a railway ticket, a decade or decade and a half ago even, and how it has revolutionized, how the Ubers and the Amazons and the big baskets have revolutionized the way we do things, what we used to do. And that is, in a way, we would call as disruption, because it has entirely changed the way we are doing things. So a disruptive innovation or a disruptive technology is something which helps create a new market and value network and eventually disrupts an existing market, right? So, if you just go back and look at how again, the examples I gave, you will be able to realize that it has disrupted. So same thing will happen in the industrial world also. As these new emerging technologies happen, they will disrupt the way you're doing things. And 5 years from now or 10 years from now, you will see things being done entirely differently. And it is up to us as technologists and scientists and students and faculty to kind of take this forward. So if you look at it, the kind of thing which happens is, typically we call them incremental improvements, breakthrough improvements, game changer improvements, or disruptive improvements. But the technology progress and the impact it has on the market is very different. So if you look at disruptive, it has a very high impact, market impact. Okay, and the technology progress is there decently, but really we would look for to be in the top right-hand corner, which is the game changer technology. But they cannot happen every day, right? You have to wait for game-changing technologies to happen. Just review your last 10 years and you can analyze what kind of game-changing technologies have come. So here is a typical Gartner's hype cycle, as it is called, for emerging technologies last year's 2020. Look at it. You'll find many of the things which we were talked about. Dr. Kota talked, Dr. General Sundaram talked, and all the speakers who have talked. You will find many of them in this curve. Okay, and about composites, about digital twins, about artificial intelligence, augmented development, everything. So this is how it is. But then you can see that most of them last year were still projected in the at the extreme left end of this curve, and it will go through this typical behavior. Everything goes through this cycle, and this is the typical hype cycle. You have an innovation trigger, then it becomes it peaks when it has inflated expectations. Then there is a trough of disillusionment which will go through, and then you will have a slope of enlightenment and the plateau of productivity. So you will have to wait for all these emerging technologies to go through this typical cycle. Many of them will fall apart. They may fall at any of these stages. Okay, but if you come to the plateau of productivity, that is when the mainstream adoption starts to take off, and that is when we say a real technology is successful. Sometimes some of them, though it may fall off at the trough of disillusionment, 5 years later, you will find that it is coming to the plateau of productivity. So there are many different things. And so the technology adoption also follows the similar thing. So we have innovators, we have early adopters, we have the early majority, we have the late majority, and we have the laggards. So this is how it is. This is the nature of things. It's not about why somebody. Each industry will have its own technology adoption life cycle. So these are very important as we talk about emerging technologies, about adoption of technologies. So this is where I think resonate very much with Mr. Krishnan, who just mentioned that, yes, all of you, again, considering that the student audience is maximum, that you will have to be patient. You will have to be willing to go through this cycle. Technologies take time to succeed. So as long as you believe in that, you will see, and you have the patience, you have the perseverance, you will see that you will make a big difference. You all have heard about the essential 8 technologies, which is, the last 8 to 10 years have been all about it. IoT, robots, drones, 3D printing, AI, blockchain, virtual reality, augmented reality. And they are impacting every sector. You can see the aerospace is listed on the extreme right, but it has, be it the financial services, be it the automotive, industrial, healthcare, energy. These 8 emerging technologies, and you can branch off into many more to this, that's never a problem, but they impact every sector. And that is why it has caught the interest of, a large majority of the world. And you're seeing more and more being done and talked about and deployed in these areas. However, so here is a survey, and I don't want to get into the detail, which kind of replicates the fact that this is what people are adopting, looking for. Those who are still behind will certainly come to that. But while we talk about all the digital technologies and about AI and ML, which we will certainly touch upon a little later, the bigger thing is also, let's not lose sight of the core of many of these, right? It's about materials, it's about manufacturing, it's about instrumentation, it's about electronics, right? It's about the engine dynamics, everything. So here is a typical components of a jet engine, and you'll see that, look at the kind of materials which are getting used, right? From aluminum to titanium to nickel to iron-based alloys, and the Inconel super alloys, where the high temperature is there. And we are starting to see that the material scenario is also changing. Newer materials are coming, they are getting used. Okay, here is an example, classic example of how the fan blade, right, which is right at the front of the engine. So as you board the flight, if you can always see the engine, and what you see is the fan blade in front. So GE introduced the composite fan blade first ever, about a few years ago for the GE90 engine, right? It was 4 feet long, weighing less than 50 pounds, and it was made from carbon fiber and toughened epoxy matrix. Delivers double the strength and 1/3 the weight of titanium. So for an aerospace industry, for commercial aircrafts or even fighter aircrafts and everything, you see that the biggest thing is the weight of the aircraft. Every gram you can reduce in the overall weight of the aircraft gives you higher fuel efficiency, gives you higher ability to higher thrust, and so on. So weight becomes a very critical. So the more and more you can change the materials which are today being used to lighter materials like composites, you will have a different world in a few years. So it has a very unique design, and and this is considered a work of art. So it was actually there in the New York Museum of Modern Art also. It looks beautiful. Those who get a chance to look at it, please look at it. So here is how carbon fiber composite fan blades on the GNX, we were able to reduce the blade count from 20 to 80, which means very significant reduction in weight. Look at how titanium aluminite blades in stages 6 and 7 have helped reduce the engine weight by about 400 pounds, which means a huge savings in fuel. So fuel, in commercial airlines and commercial aircraft, becomes the central theme, because that is the biggest cost component of any commercial airline. Again, we are looking at the world where we are moving from thermosets to thermoplastic composites. Okay, huge amount of research going on, lots of opportunity for students in the materials world who want to take this up, because the fact is that thermosets unfortunately have the disadvantages of that they cannot be recycled. So we are already facing a crisis in the wind industry. Very recently also there was a report where we have to just dump the wind blades, which are also made of thermoset plastic glass fiber composites, in the landfill, and we will soon have an kind of an environmental issue. So we have to move to thermoplastic composites. Okay, the newest one of the very classic materials which has come in the last few years is the CMCs, the ceramic matrix composite, where again GE was the leader in kind of developing this, I should say, and it is being used in the combustor and high pressure turbine for getting twice the strength, 1/3 of the weight, and of course greater thermal management capacities. Look at the top right hand curve and you can see how CMCs, the ceramic matrix composites, really expands the whole temperature domain. And if you look at it, it's starting to get used. So if you look at it, the commercial aircraft first, it will eventually come to the military aircraft at some point in time. It started with the jet engine, will certainly move to the helicopter and other engines. Currently it's being used for static components, eventually it will move to the rotational components. It started with the liner and shrouds, but go to the blades and nozzles and others. And today, obviously, it's in the high pressure zone and platform. So currently, the silicon carbide 6-SiC, as we call it, is the most popular CMC. The oxide is also becoming very popular. And so this is the kind of changes which is happening in the material world. In the manufacturing world, additive manufacturing, as you know, several people refer to is 3D printing already, is changing the world on how we are manufacturing things. So, and it's an emerging technology which is going to disrupt the entire world of manufacturing. There's a lot more, which people are studying. Obviously, I'm not going to get into the details, but this is one emerging technology which is going to disrupt the way we do things. The GE9X engine was given the FAA certification sometime in September of last year, and it has something very unique, and this kind of summarizes that. It has a 134-inch composite fan case. The fan case, of the engine. So it is the largest of any commercial engine in the world for the Boeing 737. It has more than 300 additively manufactured parts. It has the 4th generation composite fan blade installed, which I showed you. It has 16 composite fan blades, which is the lowest number, for a commercial jet engine, and it has 5 ceramic matrix components. So everything which I talked about materials, about manufacturing, is kind of summarized here, which is what makes this engine very, very unique. And this also shows that these are not just R&D topics. These are where it has taken several years to bring it into reality. So today we have engines flying with these, composite fan blades with additively manufactured parts, with CMC components also. So while, as I said right at the beginning, my domain has been entirely more about what you call inspection. So obviously I can't have a talk without referring to that. So here is how the increasing amount of composites. Even this is about the 787 Dreamliner, and you can see how composite percentage has increased to 50% here. Of course, our LCA, which has been referred to in the morning, has much higher composites. But in the commercial world, the Dreamliner has 50% composites. And the bottom, you can see the several types of defects. So you have to have quality control inspection methods which can do the inspection of these composites successfully, both during manufacture and in service, so that these planes can fly safely and without having to worry about any kind of damages. And so, I am not going to get into the details, but this is how damages, evolve, in composite materials, and we need inspection methodologies to do all that. So just referring to a few very important new inspection methodologies which have come into the become popular is the microwave Eddy. You might all have heard about ultrasonic, about eddy current, and optical, and many other methods. But here is newer methods, microwave Eddy, very good for composite inspection. So this is becoming very popular for composite inspections in both the aerospace and the other worlds. So, and it's very good for coatings also. So you can see at the bottom how the thermal barrier coating, which is a ceramic, can also be inspected using the microwave ND. Terahertz ND, which is probably getting popular in the last few years only, is again becoming popular because it can do a very good job of inspecting both coatings and composites. And both are very important for the aerospace industry, as you would hear. And it has some unique qualities, which is where the left-hand table at the bottom compares how different methods do, like X-ray, terahertz, infrared imaging, eddy current, and so on. So these are some of the methods which are going to disrupt the way we are doing inspection. These are all non-contact methods, and that is why it makes it very attractive. And that's why we are kind of pursuing research in these areas. Again, everything I'm mentioning are, there's so much to do. What I'm just showing is just the tip of the iceberg, which is where for the student community, those who want to pursue research, MTech, PhDs, there's tons of things to do in this area, which you can pursue. Here is a classic example of how the imaging using X-rays, which always used to be 2D, has now moved to 3D with industrial computed tomography. You can see this beautiful image on the right-hand bottom of a turbine blade. This is actually an aircraft engine turbine blade. You can see the kind of details which you can see, which no other method can provide you. The machine at the top is the machine, the CT machine, which actually imaged this. Okay, and you can see the cross section. So just like doctor takes slices when he images a brain for a tumor or something, you can take cross section in this 3D imaging and get to really finding out extremely fine micron level defects, which is very important when we are talking about the aerospace industry. Infrared imaging or thermal imaging is again very, very popular for imaging of composites. With the increasing in the use of composite usage in aerospace industry, this obviously will become a nice imaging tool, non-contact, wide area, very fast, very good to interpret, and we have so many different methods in that. When you talk about NDT or inspection, it is usually you do it in a static way. But you can move to structural health monitoring, where you embed sensors on the components and do the monitoring, of components. So this is again very well established. Our NAL, the Indian Institute of Science, and many other institutes have done pretty much a lot of advances in this particular area using like the fiber crack gratings, and we are now moving to different kinds of sensors, because this can monitor large structures like aircraft continuously and give you advance warning much before any potential failure can happen. And there is plenty to be done here also in this area. So that's kind of a quick touch on materials, manufacturing, and inspection. And now we'll move to the emerging trends in the whole digital world, which we are talking. And that is we call as digital transformation, Industry 4.0, which was referred to by Chandra Sundaram and Dr. Kota again. So the world is getting digital. There's no doubt about it. Okay, and there are different terminologies, but we want to go. But basically the Industry 4.0 is driving us to utilize these technologies, be it in the AI, be it the advanced robotics, be it additive manufacturing, the digital twins and analytics, to kind of bring everything together to make this world a better place to live in terms of quality products, in terms of utilizing of information, which is available in much greater quantities today, which is what we call big data and so on. So obviously the trends here, AI, robotics, internet, IoT, human augmentation, extended reality, 3D printing. So this is just to show it, and these percentages are not to give too much importance to them, but they keep changing depending on the industry you're looking at. But they are all there. They are all there. And a lot of discussion happened about deep learning, machine learning, and AI. Like it or not, these are going to be kind of our core about our framework, and they make our systems efficient. So why not? So here is an example of how we have used it for ultrasonic inspection. The ultrasonic inspection, when the data comes out in the form of a signal or an image, how we have used AI and machine learning to completely automate that inspection process and come to a decision making. Of course, we talked about IoT. I mean, the sensors world cannot survive without IoT in the near future. So IoT is going to be another very, very big thing, which is going to be a breakthrough for all of us. Of course, you have all heard about Industry 4.0. I don't have to highlight that, but that is transforming itself into different domains. So when in my world of non-destructive evaluation, we call it the ND 4.0. Okay, you go to the another world, they refer it to Dash 4.0, and things are right. But it has impacted and will continue to impact the industrial world in a very big way. And the more we align, and that is why I kept saying these are all interdisciplinary. So when you talk about materials again will utilize the fundamental technologies of Industry 4.0 to its advantage, of how AI is going to be used in material development, newer material development, and so on and so forth. And of course, one of the big things for Industry 4.0 is automation. Automation in every sphere, right? Be it in manufacturing, be it in quality control, be it in analysis, be it in doing the inspection, being it kind of coming to the decision-making process and so on. Automation is the buzzword. And why not? Because it provides a speed, quality, productivity, reliability. All these are drivers. Safety, harsh environments, nuclear industry, of course, even in the many other industries like chemical and all. That is the driver for automation. Even in aerospace, large areas is what we have to inspect, and that is the driver for automation. And of course, very intricate. When you talk about an aircraft engine, we have extremely intricate parts to be inspected inside, and probably very difficult to do without automation. Okay, I have quite a few videos, so let me see. I'll probably run a few of them. In the interest of time, we may not be able to, but this is how, is the concept of how Rolls-Royce is utilizing. Sorry. So that hopefully tells you where the world is moving. Sorry. Yeah. So that's an example of snake robot and swarm robots, which again was referred to. But engine maintenance. So one of the biggest things commercial airline has as an issue is downtime. Every minute a plane is on the ground, the airlines is losing money. They have to have the aircraft flying as much as possible continuously. And if you had to rip open the engine every time to do the inspection, it takes several weeks, and more. So the more we can do this kind of automation and help in a way that we don't have to remove the engine, from the aircraft, but use these advanced technologies like snake robots to do the inspection, you'll be really helping the airlines, of course, make more profit, but keep the aircraft flying. Similarly, a lot of things was talked about drones. Drone also is being used very effectively. Again, I'm looking at it from a viewpoint of how inspections are done. An aircraft is a large, covers a large area. So Airbus here has done using drones to do a quality inspection at the end of the production process before aircraft delivery. So this is something which is becoming, so you can even do, so otherwise a visual inspection using a camera, even you had to do the whole aircraft will take several hours. but this, I think now they are bringing it down to, close to 15 minutes or less. So here is how drones can be used for the inspection of, aircrafts very, very effectively. Of course, I talked about automation. Automation is also in the, how you, when you inspect components like the turbine blade, I talked about how it can be entirely automated, So how, one second. So how it can be entirely, so the, what we call as ADR, the assisted or automated defect recognition, again using image processing, AI and ML techniques, where the defects in the turbine blade, once we take the radiography or CT image, is entirely automated. So automation is there everywhere. Here is a sample how Airbus is viewing it. Kind of everything you can see is a very complicated thing. Can't talk about it much, but you can see that every single action is getting automated. Either by the Airbus themselves or by the suppliers, be it the instruments, be it the sensors, be it the software, and be it the applications. So very, very ambitious roadmap, which which clearly shows that we are thinking so ahead about how we can automate the entire inspection process and so on. So here is how different technologies will come together, be it a robot, be it a drone, and combine it with various inspection devices and inside the hangar, so that you can do inspections as fast as possible. So clearly, convergence of technology is what is going to happen, but the development in each of these individual technologies is equally important. Here is also again, how the post the inspection, how the data is going to be analyzed and reported, and finally you have to figure out whether any damage has happened. If a damage is there, what is its size, whether it's harmful for the aircraft, and so on and so forth. So here is again a convergence of so many different technologies, including something which is capturing a lot of imagination now, is what is called as augmented and virtual reality. Okay, so and when you bring all these together, we have to use something called the data fusion. Okay, when you have so many technologies, the information we get is complementary in nature. Here is a classic example of how offline measurements and online measurement sensor, the data which has come, we do a sensor data fusion, again use a lot of AI and ML and many other technologies. Eventually, the final goal is at the top, the actionable information and insights which you get, and that drives the maintenance activities. We all again heard a lot about digital twins. Digital twin is again something which is going to disrupt the way we do things. Is basically having a digital model of a physical asset. The moment we have a digital twin, it just opens up a world of opportunities on how we can really improve the outcomes of anything which we do. Combine the knowledge of the physical asset, have its inputs in design and manufacturing, service operations, combine that with AI and enhanced learning, continual learning, and then you can get excellent insights which can constantly help do better in performance of your aircraft engine, aircraft, whatever you have, and so on and so forth. So basically, at the end of the day, we are trying to see how we want to combine effectively robotics, inspection, things like digital twin, to get outcomes, which is improved reliability, maximize performance, improved safety, and so on. And then we are moving into the a different world of analytics, where we are moving from predictive to prescriptive analytics, which is going to be used extensively, especially in the domain of maintenance. As you know, aerospace, one of the biggest things to be paid attention once things are in service is effective maintenance. So we have moved from a reactive to preventive to predictive to prescriptive maintenance, which means the machines themselves help you decide how to avoid the predicted failure. So that's like a dream come true, right? And then, but it's not far away. It's not far away with the technologies we are seeing. It's not far away that prescriptive analytics will be something which you'll see very much. And then, of course, we have gone into this world of augmented reality, virtual reality, and mixed reality. Again, in the interest of time, I'm not going to get into the details. Lots of stuff available out on the literature, but these are now starting to be practically used. And just even in the aerospace ecosystem, it is being used everywhere. Be it the technology, products, service solutions, applications, components, including marketing and finance. Okay, And this is just a snapshot of one of the surveys of how aerospace is trying to use augmented and virtual reality. And you can see, from the right-hand side pie charts that already, a big chunk of the industry is either has utilized it or is planning to use it or is in the process of, doing pilots and getting where you want. And it has great applications in the manufacturing, in the MRO, in the parts and supply. Okay, even in for complex assembly, aircraft is really a complex assembly. So they have already demonstrated that it has a 32% increase in productivity by providing guided instructions, through these AR kind of glasses. Quality control, of course, parts management and kitting, maintenance, repair, airline ground operations, training and upskilling. Plenty of applications on training and upskilling, which again in the aerospace industry, for the ground maintenance staff, for the engine maintenance staff, everybody needs a lot of good training. So here is, I guess, one more video which we'll play. Probably that will be the last one we'll play. Okay, so that hopefully gave you a feel of the AR VR. There's lots more. I have many more videos, but in the interest of time, I don't think I'll be able to play that. But yeah, anyone who is interested can get in touch with me, and I can share. We just for information, we ran a 15 hours 1 credit course on augmented and virtual reality for aerospace in one of the engineering colleges in Tamil Nadu just last month. So we really collected a lot of information and figured that out. So we can always discuss more on that. So immersive design through VR, I mean, it's a beautiful way of really seeing through an engine, which is a very complex part of the aerospace industry, and really help in design reviews and many other things. And already people have very clearly shown that there is lots of benefits. Worker efficiency, knowledge, reducing errors, which is very important. Improving real-time collaboration, especially in the COVID situation when people were spread out, collaboration, real-time collaboration, and of course, happy customers and cost savings. It does solve real-world problems. It's not a fantasy anymore. It does solve real-world problems for everybody. So it can be used, of course, in the maintenance aircraft MRO, and many of them have already started adopting that in various different ways. For training their people, for really having digitized version of the manuals, which is can be put on the glasses, AR glasses, and you don't have to carry bulky stuff, and everything is guided. So obviously, typical challenges in the aerospace, why AR VR becomes very useful is large structures, lot of visualization, assembly and manufacture, safety requirements, and of course many of those things. So this really helps you because MRO procedures also keep changing as directives come, the ADs come from the DGAQA or anybody else, and you need to constantly do different things. So here is how the mixed reality, where we combine both augmented and virtual reality, can give you an entirely hands-free experience of looking at a very complex engine structure, doing maintenance at a much more thing. So here is how digital data is superimposed on physical objects, making your life easy to visualize things. Of course, designing, when you design engines and design various components and how it goes into the assembly, it can really enhance the training delivery and effectiveness using mixed reality. And of course, the biggest thing is that it accelerates time to information. You can get everything very, very, very fast from the field to the control room and wherever you're doing. Eliminate all the manuals. And of course, Lockheed Martin, as they say, has been using it for their space systems, and they have included a 95% reduction in time it takes technicians to interpret their drawings. So that's a huge, huge reduction in terms of efficiency. Aeronautical maintenance, we talked about. Here is again a Lockheed Martin example using AR manufacturing instruction, which is getting through his AR glasses and doing the entire maintenance very effectively. Again, I'm going to skip this in the interest of time. So the COVID-19 pandemic, while it has caused us a lot of distress, and yeah, we have lost people, we have lost man hours, economy has gone into doldrums. One of the, if you want to look at the brighter side of things, that it has helped accelerate many of these disrupting technologies. Many of these disrupting technologies people were forced to use, industry was forced to use. What would have potentially taken several years for adoption, frankly, we have seen in the last 1 year, many people adopting it. Here's a classic example of how remote inspection of aircraft engines, all the engines have to undergo regular maintenance checks and inspection. And here is a classic case of how the airline industry used remote inspection to do that, which was never done much earlier. And interestingly, even FAA, which kind of mandates many of these inspections, they came up in April 2020, which is within 2 months of the striking of the pandemic. They came up with a remote inspection guidance and authorized airlines by which they could actually do, where the expert was sitting somewhere else in the world and a technician was near the engine, and they actually used a lot of remote collaboration tools and did it. So just to give you an example of how innovation opportunities was utilized during this pandemic. And there we come to the end. So there have been several disruptive trends, several disruptive technologies in the emerging technologies, a lot of scope to do tons of things. We have just touched the tip of the iceberg in what these technologies, how they can be utilized, and so on and so forth. So in summary, the pace of new and advanced technologies emerging is increasing rapidly. All indications are that they will disrupt the aerospace industry and other industries in a big way in the next 3 to 5 years, if not earlier. Interdisciplinary domains provide a huge opportunity for accelerated growth and impact. And in the context of students and academic institutions, that is the main thing to do. Everything is today interdisciplinary. And how best you can have your curriculums which can combine these things and give them exposure to what the future will be demanding will be the key for our like Atmanirbhar campaign to succeed, because it has to be done that way. Need for additions to curriculum to expose students to the future. Of course, nothing can work unless the academia, the R&D, and the industry collaborations are pushed forward. And because as you saw in the technologies, the opportunities are huge, but unless we all collaborate together, there is not much we can do. So this is the recommendation. I would say we all have to work together, and the only way is to continue to innovate, evaluate the technologies, adopt them, implement, and move forward. With that, I thank once again Dr. Ramesh and Gopalan College of Engineering for having given me the opportunity to make this presentation. Thank you very much.
So thank you very much for an interesting presentation. It's really mind-boggling to look at the way things are happening, and if the students community has to get connected to this kind of technology, I also would like you to suggest in the next webinar, how do we go about looking at getting these kind of things accessible to students in some sense, like virtual inspection, you said, the kind of MI and AI in a kind of inspection, testing, all those processes. Is it something which can be tried out in an institution like a small private engineering colleges? If there are ways out of that, I would like you to personally, this is my other thing. This is one thing which definitely will interest everyone in view of the kind of great potential and the kind of challenges and also the kind of interest that it is generating now. So that's my personal suggestion and my concern also.
Yeah, it will be my pleasure to help in any way both the academic community and the students in taking this initiative forward.
Yes, sir. This is something which we need to look at really at this thing to take further this thing. Now students are expected to do interdisciplinary work and also to work across the departments. So definitely we'll come back to you on this and things, sir.
Sure.
So Archana, if there are questions again, my sincere thanks and also sorry for this delayed this thing. We were sliding for some reason which are beyond our control. So if there are a couple of quick questions, we can this is one subject everybody will have a lot of interest. So I don't want to stop that.
Vivek sir, is there any questions?